Let's look at some example histograms that I've collected from across the years. Here's a histogram of the U.S. household income distribution for 2008. And I just downloaded stuff from a census website, a table of how many people in each income category, and then did a bar graph of it, which should be a histogram because it shows how many households were between 0 and $2,500 and how many were between $2,500 and $5,000, etc. I think this might be before counting government assistance, like the Supplemental Nutrition Program. So does this make sense to you? Is there anything strange about this graph? Pause the video and think about it. Okay, 3, 2, 1, pause. Okay, I think a lot of people notice that it seems to be saying like the most common income to have is $100,000, which hardly any of us believe. But if we look at the labels really closely here, this is from $100,000 to $150,000. So that one category is $50,000 wide, where each of the rest of these are only $2,500 wide. So this bar should really not be this skinny. It should be much, much wider and lower to compensate for that. And all the other upper bars here are also much wider than the lower bars. So you have to watch out for bars that aren't the same width in the histogram or in the table. I did some heavy-duty processing on this to make it more reasonable and came up with this. So most people, so the median, $52,000, is right around here. Half of the households make less than that and half more. The mean is $68,000, which is a bit higher here. And we'll talk about mean versus median on a histogram in the next section. Here's a zoom in on it, and we'll come back to this shape. This shape is called skewed right. Even though most of the data is to the left, there's a long tail to the right. And so someone 100 years ago decided that that should be called skewed right. I have data on a bunch of other things. Here's house sale prices in Davis, California, which is near Sacramento. That also looks skewed right. Here's number of bedrooms in each house for thousands of houses in the San Francisco Bay Area. It's a little bit skewed right because there are some here at 6 and 7 and 8 bedrooms where you can't go that far down below the mean. But overall it looks fairly symmetric. Here's the square footage, the size of each house. That's a bit skewed right. Here's more sales data. I'm not sure what happened to my histogram here. It should have a nicer peak to it. But again, that's skewed right. Now here's data from a math110 exam from years ago, and it has most of the data is to the right with a tail out to the left, so that actually means it's skewed left. So this must have been an exam where everyone had enough time to study and got mostly 80 and above. You can get a little more X resolution by making the bin widths just 5. Here's data from a kind of social science public policy paper about exposure of children to lead in their drinking water and their paint chips in their house and such. So this is the actual amount of lead in their blood. Would you say that's skewed right or skewed left? We can use this in demographics. This is something called a population pyramid, and we'll see why in just a sec. It tells us the number of people in each age range split by male and female. And remember, way earlier in the semester I said you can figure there's about the same number of people in each age range from 0 to 80. That doesn't turn out to be exactly true. There's kind of twice as many 40-year-olds as there are 60-year-olds. But compared with what we're about to see, it's roughly true, and it's certainly easier to remember. Now, this isn't showing the probability of dying at each age. This involves that, but it also involves how many people were born 25 years ago, how many people were born 20 years ago. So it incorporates baby booms as well as mortality. So why is this called a population pyramid? Well, if we show it for a region that doesn't have all the advantages that we do, then it looks a lot more like a pyramid. And that's a mix of various historical injustices and current injustices and such that you can study in other classes. Everyone's talking about commute times, unless there's a pandemic. But the census has collected data on commute times, and it turns out the average is about 30 minutes. Here you can see this bin width was wider, and so they made the bar proportionally smaller, so it all made sense. Let's talk about sports, because some people like sports. Here's a histogram of how many runs per game each team scored for 4 years across all teams in baseball. Looks skewed right to me. But then you can break it down by by like just one team for 1 year, and it still looks skewed right, but it's a bit jumpier because the data set is smaller. It's just one team instead of all 30 or whatever teams, and it's just 1 year. We've talked about inflation. Here's a histogram of inflation across the years. You can see it's mostly in the kind of 0 to 2 to 4% range, and it isn't particularly skewed right or skewed left. Here's how much money the stock market returns, like tends to go up or down each year. Again, not really skewed right or skewed left. Anyone's thinking of going to law school, here's an interesting histogram of starting salary the first year out of law school. And that looks kind of skewed right here, but skewed left here, and it's got two big bumps. So we call that distribution bimodal.